Hello everyone. I wanted to work free problems from one of the more difficult chapters we've had and will have this semester, and that is the chapter that deals with absolute value, both in equations and in inequalities. This stuff gets very complicated very fast, and the traditional way of teaching it is to have the student learn some rules that cause the absolute value to vanish. And that's the way I've always taught it, but I think I found a way of actually hacking these things, of thinking your way through them, and it builds on stuff you already know. Now, no matter what technique you use, your first move is always going to be to isolate the absolute value. And so what I want to do here is subtract 1 from both sides. And a very quick and easy first move indeed. So subtracting 1 from both sides, we have this. Now, at this point in time, you would invoke a rule and not know why it works, or probably even not even care why it works. And if that works for you and you're content with that, that's fine. But let's actually hack this. Let's actually build on what we already know. The first thing I want to do, though, is to make sure we do know that. I want to sort of survey the course as a whole and to tie together some ideas. In other words, I want to look at the absolute value in terms of function notation and inputs and outputs. I'm going to call what I put inside my absolute value the input, and I'm going to call what comes out of it the output. In other words, really what I'm going to do is graph this function right here. Before I do that, though, I know, of course, that normally we write y to the left. I'm writing it to the right here just to show you that the input is going to be the x and the output is going to be the y. That's the input-output model of the universe that our mathematics catches so well in terms of the x and y axis and various functions. Now, I want to graph this function here, but first I want to point out something that you already know about absolute value, namely that the output will always be greater than or equal to 0. That's what absolute value does. It takes negatives and makes them positive, and it doesn't alter positives. Now, let's get at the graph here to really get a visual on that. Here is the graph of the function right here. The absolute value of x is equal to y. Notice my x-axis, I've regraphed it. I'm calling it the input, and I'm calling my y-axis the output. And the function, as far as I know, the absolute value function is the only one that speaks its name. A v, absolute value. And there you see it. And notice the points, the red points, are all in the northern hemisphere. There are none down here in the southern hemisphere. And the northern hemisphere is where y is positive. The southern hemisphere is where y is negative. In fact, the minimum point on the function is at y is equal to 0 here. And that's what we knew. No matter what we put in for input, we're never going to get out anything smaller than 0. It's always going to be positive or greater than 0 or equal to 0. Now, that in itself is an amazing thing. You can really create some tricky math puzzles with that idea. And in fact, there's a link in the description of this video that will take you to some of these teasers that show you how complicated and tricky they can be. But if I was to give you one of these tricks sort of stripped down to its core essence like this, I think right now that you'd be very certain here and would simply, grin and wink and say, hey, come on, there's no solutions to that. And you'd be right, and you could move on to the next problem. What comes out of absolute value is always going to be 0 or greater. It can never be negative, so there's no solutions here. Now, the problem we're going to be working, as you'll see in a second, is really this one right here. And we'll get back to that in a second, but I want to point out and use this to illustrate the fact that absolute value has a split personality. There are, in fact, 2 values at work in there for x. These are the 2 values. X can be 3 or x can be negative 3. Both of those values, when you put them in for x, will work. And you can see that on the graph. If I let x equal 3 and chase it up, and then chase it over to the output value, you see that y is equal to 3. If I let x equal negative 3 and chase it up and over to the output, you see that once again y, or the output, is equal to 3. So there's 2 answers here. X can be 3 or x can be negative 3. And this is the dual split personality that makes absolute value such a chore to deal with, and why they have created these rules to, in a sense, streamline and eliminate your thinking. Of course, the problem is that you will forget the rules or you will apply them wrong, and so thus the hack, which is to bring back thinking, bring back your mind into this thing. And so let's get after that hack. There's the original problem, and I've subtracted 1 from both sides. Now at this point in time, instead of evoking a rule, I'm going to use what I call the cover-up method. I'm going to put my finger over what's inside the absolute value, and I ask you, what two values will work? We just went through this on the previous page. We know that 3 and -3 will work. What's under my finger has to be either 3 or -3. Well, what's under my finger? Well, t minus 7. And so we need to put a t minus 7 here and a t minus 7 here. Now notice what's happened. I've thought my way through this by covering up what was inside the absolute value. I didn't use any rules, and the absolute value is gone now. And I've got 2 conditions, 2 equations, and 2 unknowns to solve down here. All I need to do is add 7 to both sides. This is very simple. And so we do that. We add 7 to both sides, and we discover that t is equal to 10 and t is equal to 4. Very sweet and very easy. And I suggest that you take the time to try t is equal to 10 in the original equation and t is equal to 4 in the original equation, just to satisfy your curiosity and to see and to hammer home the idea that absolute value has this dual personality that you simply have to learn to deal with. Now, let's get after that other problem I wanted to work, the inequality, and let's use the cover-up method on that. The absolute value has already been isolated there, so I'm just going to recopy this so that I can show you the cover-up technique. I'm going to cover up what's underneath my finger, what's inside the absolute value. I'm going to cover it up with my finger. And then I'm going to ask what values under my finger will satisfy this inequality. And I'm going to use a number line to get at that. Now, you don't have to use this, but when your first few times of learning this technique, it really helps to draw this number line and to ask yourself, what works under my finger? And you play around with that. You try different numbers. If you try 18, it's not going to work because the absolute value of 18 is 18, and 18 is not less than 18. If you try something in here, say like 9, it works. The absolute value of 9 is really just 9, and 9 is less than 18. In fact, all of these values to the left of 18 work. Even these negative values work. If you try, how about negative 17? The absolute value of negative 17 is 17, and 17 is in fact less than 18. All of these values inside here work. And in fact, if you try a few values outside here, like say like negative 100, or how about positive 20, if you try those don't work. And so very quickly you're able to color in the conditions that have to be met by what's underneath my finger. What's underneath my finger has to be less than 18, and it has to be greater than negative 18. What's under my finger has to be less than 18 or greater than negative 18. Well, what's under my finger? And the answer is x plus 2. Now, there you go. I've gotten rid of the absolute value. I've thought my way through this. It wasn't that difficult. It didn't take some great ingenuity, and it didn't take some rule that I don't know why it works. I just apply it. It simply hacked the problem by thinking. And so now we're not quite done, of course. We need to subtract 2 from all sides, but that's simply done. I'm going to subtract 2 from all 3 sides. And when I do that, we get the answer. X has got to be less than 16, and x has got to be greater than negative 20. Now there's the answer, and I could decorate that up in more formal set builder notation, or I could graph it. If I was to graph it, I'd suggest you graph it like this, that you use, instead of the open circles, you use the parentheses, because then I could find the interval notation simply by reading it off. The interval notation would look like this. Like this. But either way, either of these is good. The interval notation is good, the graph is good, or the set builder notation solution is fine. Either one of those works. But the idea is this cover-up method, and using your native ingenuity and not succumbing to these rules which I see are misapplied all the time. So that's the cover-up method. It's definitely a hack. I haven't seen it in an algebra textbook. Maybe someday, huh? Be talking to you soon.